Hi, Brad Monday here, contributor and co-maintainer of Chassis ML, the open source Python library for automatically converting any machine learning model into a production-ready container. In this short video, I will highlight and demonstrate some of the key enhancements, including faster build times, smaller containers, and more multi-platform support. Let's dive in. First, you may have already come across the Chassis repo, which lives in the Modsy organization. Here, you will find some helpful resources, including examples, the source code of course, and some quick start instructions. What you will also see are links to Chassis's home documentation page. For those who may already be familiar with Chassis, you'll notice a change here. First in the domain name to chassisml.io, and you also might notice that these docs are versioned to correspond with older versions of Chassis. So if you happen to be using a legacy version, you can continue to do so with the supporting documentation. Now, regardless of your familiarity with Chassis, let's do a quick overview of what the library does. In a nutshell, the Chassis Python package will convert your machine learning or deep learning model into a production-ready Docker container. Now, if working with Docker, gRPC, or building API servers seems daunting, not to worry because Chassis handles all of this automatically for you. And with support for all of the most common Python, ML, and deep learning frameworks like PyTorch, TensorFlow, scikit-learn, transformers, and others, Chassis can coexist alongside your model training and development environments. Now, when you execute a Chassis build job, the resulting container is an immutable, portable, lean, and scalable representation of your model. Included in this container are a few items. First, your model weights files and artifacts. Second, any dependencies required by your model to run, like Python libraries, specific language versions, etc. A customizable model card of metadata that comprehensively documents your model. And finally, a gRPC model server that adheres to the Open Model Interface specification. This is the key component that makes your model consumable with an easy-to-use API. And with the latest 1.5 release, you can build these containers faster than ever. This release culminates a significant refactor of the Chassis codebase. And some of the key improvements include a performance boost that yields build times of up to 5 times faster and up to a 10x reduction in container size. A local Docker build option, which means Kubernetes is no longer a requirement to work with the Chassis package. Support for multi-platform builds, a considerably less resource-intensive service, and a lot more. Now, let's check out the Getting Started guide to see an example of how this works. Okay, here on the Getting Started page, we have two options. The Quick Start guide uses an embedded model that is pre-configured to get you up and running immediately. However, this abstracts away much of the user-required actions, which, frankly, are important if you're interested in using this for your own model. So instead, we're going to follow the full Chassis workflow guide. Now, the first step is to simply pip install the Chassis package in your preferred Python environment. Make sure to include the Quick Start extension to install the extra dependencies required to use the Quick Start model. I've gone ahead and copied and pasted this into my virtual environment ahead of time, so Chassis is already installed. Now, I'll simply copy the snippet of code into my Jupyter notebook and run this cell. Now, as Chassis is running, let's take a look at what's happening here. First, we're loading a digits classification model that the Chassis guides module makes available to us. It has been trained in scikit-learn and saved as an embedded pickle file within the package for convenience. This model is great for testing and learning how the tool works. Next, we will define a single predict function. You can think of this predict function as your model's inference function that can access any in-memory objects, and in this case, that's model. So this function will expect a mapping of string to bytes and return a dictionary where the key is a string and the value is some bytes. And this function will start by taking the input digits image bytes, processing it, passing it through the predict proba functionality, process them, format them, return them, and ultimately encode them to match our function signature. Then Chassis will do the rest. Here, I'll create a Chassis model object, simply passing through my predict function that I just defined. I'll then add the pip requirements this model needs to run, scikit-learn and NumPy. I'll provide some metadata about my model, namely the name and the version. I'll define my inputs and outputs. And the guides module also provides a convenience piece of sample data to run a test inference. Finally, I'll elect the local Docker builder option to build my container image, passing through the container image name and tag. And as I scroll down, I can see the logs of a successful test run and container build, all in less than a minute. And what's great about this is I now have a container I can run anywhere I'd like, in the cloud, at a small form edge device, or even right here on my computer. To do so, I would simply go back to the Getting Started guide, spin up my container using this docker run command, copy paste this code into my Jupyter notebook, and run a successful inference. Make sure to go check out our latest 1.5 release at chassisml.io today. We can't wait to see what you build. Thanks for watching.